Hello everyone, my name is Finding Pepper and welcome to episode 2 of the Dungeon Crawler tutorial series. This episode we're going to add a player who will have basic movement and collisions. So of course we'll start by going to get our costumes from the YouTube tutorial assets project. Alright, now we're here. A link to this will be in the description, but grab this DC2 sprite and put it in your backpack and head back to your original project. Alright, we'll get it out. We'll rename it Player. And you'll notice that I am using the same player sprite as Griffpatch's RPG. That was just because I didn't feel like searching very far to find a player sprite, so I just took that one, but I definitely encourage you to make or find your own player sprites, and same with the tiles too. Alright, I also think it's a good idea to create a main loop sprite. This sprite will just run everything basically. So we flag clicked, we'll broadcast a message called setup, wait, and then we will broadcast start main loop, and without a wait. And when I receive start main loop, I'll just put a forever loop. And here we're going to broadcast some messages. Broadcasting multiple messages here allows us to control the order in which things happen. So I'll start by broadcasting move player. Then we will display tiles. And then finally we will display player. Great. Now in the tile sprite we need to modify some things. I'm going to move the set variables to the main loop sprite, and I'll change this to when I receive setup, and I'll put stamp tiles under when I receive display tiles. The main loop, we'll just stick these under the green flag clicked, run it, and it should behave exactly the same. You should still be able to place tiles. Now let's begin coding our player. We'll start with when I receive setup, make a custom block called reset, run without screen refresh, put it under setup, and here just going to have a simple go to the middle of the screen. And it's hidden right now, we'll show it. Alright, it's very small, we'll fix that later. Alright, sorry, back into the main loop, because we're going to create some better control handling. So before we do anything else, we'll broadcast the message check controls. When I receive check controls, let's create some variables for the sprite only to store the controls. Up, right, left, and down. I'm going to set right to right arrow key pressed or D key pressed. Okay, and you'll notice I'm putting a boolean into a number input, or string input rather. Now if you put a boolean into a number value like this, it'll be turned into 0 if it's false or 1 if it's true, which is a pretty cool trick. But putting it into this will just make it either true or false. So we're going to round this. So now I'm pressing the right arrow and it's 1. Okay. Now we'll set left to left arrow key pressed or A key pressed. Set up to up arrow or W key pressed, and set down to down arrow or S key pressed. So when I receive move player, let's make a block called move X. We'll make a variable called speed X to hold the player's speed. Okay, so in the move X block, I will change speed X by right of main minus left of main. So if we're holding the right arrow, it'll be 1. If we're holding the left arrow, it'll be 0 minus 1, negative 1. And if we're holding both or neither, it will be 0. Now I'm going to multiply this by 5 so we get some better acceleration. Now I'm also going to set speed x to speed x times 0.5. So for example, if we're not pressing right or left, then we will come to a halt pretty quickly. Now I'm going to change x by speed x. So pressing the left and right arrows, we're moving left and right. You can easily duplicate this for up and down, move Y, run without screen refresh, and duplicate these blocks, change the X to Y, speed Y, change Y, and then up and down. So now we can move in all the directions. You'll notice if we're moving diagonally, we're moving way faster than moving just side to side or up and down, because we have both X speed and Y speed. So let's decrease that. I'll make a block called decrease diagonal speed. Run without screen refresh. And here, if the absolute values of speed X and speed Y are both greater than, say, 1, the reason I'm not saying 0 is that there can be some rounding issues, and so this will often apply even if we're moving in just one direction, if we say 0. But that's why we're saying 1. If it is, then we'll set speed x and speed y to speed x and speed y multiplied by 0.6. So now the diagonal is a more reasonable speed. Now let's add some animation. So when I receive display player, and here we'll set our size to correct. So we'll set our size to, and we'll do it based on the tile size variable, tile size over 16, because our player is 16 by 16. And then again multiply it by 100 to make it a %. So we'll see now we're at the correct size. Now let's say if our speed is greater than 0, so we'll use an OR, because if we have speed in any direction, we will want to display the walk animation. So switch costume to join player walk, and then we want a number between 1 and 6. So we'll use the timer variable, and this increases 1 a second. So we'll multiply it by 8 to get a better speed. We're going to round this to get a whole number, integer, and then use modulo, mod 6, because there are 6 frames. We'll get a number between 0 and 5. We want a number between 1 and 6, so we'll just add 1 to this. If you don't know what mod is, it's essentially remainder. Now we'll do the same for player idle. Now we have 4 directions, so for now I'll just do the right direction. Player idle right and player walk right. So now you can see they're animating, and when we walk, we display the walk animation. But we don't turn around when we move in different directions. So let's change that. Create a new variable called dir for the sprite only. we're making a custom block called change direction. So, if speed x is greater than 0.1, then we're moving to the right. So we'll set dir to right, and then stop the script. If our speed x is less than negative 0.1, then we'll set our dir to left. Now if neither of these things are true and the script is not stopped, then if speed y is greater than 0.1, we'll set dir to up, and if it's less than negative 0.1, we'll set dir to down. And if none of these things are true, then we're not moving, and there's no need to change the direction. Now we'll use the dir variable in our animations. So we'll join player, walk, and then the dir variable. And then the same for idle. Player, idle, dir. Cool. Now we face in our 4 directions. Let's make a variable called animation frame for the sprite only. And we'll change animation frame by abs of speed x plus abs of speed y. And we're going to divide that by 12. It's just an arbitrary number. Our goal with this variable is that if we walk faster, we will animate faster. So we'll replace, in our walk animation, we'll replace the timer times 8 with animation frame. Keep the round, of course, and everything else. So now, if we walk slower, our animations are slower. And if we want to go to the idle animation sooner, we might want to change this to more like 0.25 and 0.25, or even 0.5. Okay, great. This is looking good. Now I'm going to put our animation in a custom block called animate player and run it without screen refresh, of course, like always. Stick it under display player, and then I'm going to stamp and hide. Now I could just show the player, but I like to use the stamp block so I have more control over layering. And it behaves nearly the same. If we don't like the fact that the pixels can be uneven sizes, you can maybe mess around with the settings in Turbo Warp. There are some things like high quality pen, and you could change the screen size to be more suitable to 32 by 32 tiles. Just some ideas. Anyway, next we have collision. Yippee! We'll start with x collision. So we're going to change this change x by speed x to a repeat loop, where repeat speed x, repeat absolute value of speed x because it could be negative, and then change x by 1, except if speed x is negative 1, we want to change it by negative 1. So we'll do speed x divided by abs of speed x. So this will get us 1 if speed x is positive and negative 1 if speed x is negative. Now, we need to store the solidity of the tiles. So I'll make a list called tile shape, and this will be familiar if you've done GriffPatches tutorials. So for each tile, I'll just put a blank value in the list, empty string if it is not solid, and I'll put a hash if it is solid. Perfect. Go into the player sprite, and we need a way to check what tile we are on, or what tile is at a certain position. So I'll make a block called get tile at x, y. Alright, so we need some way of converting an X and a Y position to a tile index. Make a new variable, tile index, for the sprite only, as well as tile and tile shape, all for this sprite only. That will be what our getTileAt block finds. So we'll start by finding the tile index of the leftmost tile in our row. Alright, so to find the leftmost tile at our row, we're going to start by just finding the tile Y position. And by that I mean like the bottom row would have a tile Y position of 1, and then the next row up would be 2, etc. So we clearly need to divide Y by tile size. We also need to subtract half a tile, so that'd be 0.5. Without changing half a tile, this would find the tile as if 0, 0 is in the middle of a tile. So we need to subtract half a tile. Now, in our standard XY coordinates, the bottom left is negative 240, negative 180. But in our grid coordinates, that would be 0, 0. So we need to add grid height divided by 2 to this. And like I said, the reason we are adding grid height divided by 2 is because, think about if the player was in the bottom left of the screen, his coordinates would be negative, but on the grid we want this to be 0. And we are doing division, so we need to round this. Because each row contains grid width tiles, we need to multiply this number that is sort of the tile Y by grid width. So this will find the tile at the left of our row, so we'll just set tile index to this number. Now we need to change tile index to find the tile index that we're actually at. So we'll do something similar to this, replacing the Y with the X and grid height with grid width to find the tile X. And then this would make the bottom left tile 0, because 0, 0, 0 plus 0 is 0. So we need to add 1, because list and scratch start at 1. So the bottom left is tile index of 1, even though the tile X and tile Y positions are more like 0, 0. Alright, now that we've found our tile index, we can set tile to the item in item tile index of grid. So this gets the tile that is at the position. And we can set tile shape to item tile of tile shape. So this is finding the index in the tile shape list of our tile, and whatever item is there is what our tile shape is. Awesome, that is the getTileAt block done. Now it's time to actually code collisions. GetTile at X position, Y position. So there are two cases. Either we are moving right and so we should be pushed to the left, or we are moving left and we should be pushed back to the right. If tile shape is hash, so if we're on a solid tile, then if speed x is greater than 0 and we're moving to the right, then we'll change x by -1. And if it's less than 0, we'll change x by +1. So we want to push in the opposite direction that we're moving. We also want to set our speed x to 0 here. So let's try walking to the right into a wall. We'll see we cannot walk into it. And to the left, same. We can, however, still walk vertically, although when we're inside of the wall, we cannot move left and right. Great! Now I'm going to put this into a block of its own called handle x collisions. Run without screen refresh, and we'll give it a X and a Y position. And replace the X and Y here with X and Y. And then we can just handle X collisions at X position, Y position. Or we can do better, because if you'll notice, the center of the player is colliding with the wall. Let's create variables for height and width for this sprite only. These variables represent half of the player's either width or height respectively. So I'm going to make height 14 and width 10. While we're here in reset block, let's also set speed X and speed Y to 0. Now we'll handle X collisions at X position plus width and X position minus width. So on the right and left sides. We can do the same for Y position. We'll do Y position plus width and then Y position minus width. So we have each of the 4 combinations, each of the 4 corners. These will be height variables, not width variables, of course. So now we collide with the edge of the wall, and our head does as well. Although, of course, we can still move vertically through the wall. Let us fix that now. Much of the code will be the same, so we'll just make a new block, handle Y collisions, X, Y, and with that screen refresh, and then duplicate this code, replacing speed X with speed Y. We can delete the change Y by speed Y block, because that's happening inside the repeat loop. We got replace all the X's for Y's. And then the handle X collision blocks will be replaced with handle Y collision blocks. Again, we're doing all 4 corners. We'll again duplicate the X code for the Y code, but replace the X's with Y's. Cool, let's try this. And we can now no longer walk into the blocks. Alright, I just have one more thing I'd like to do in this video, and that is to have a toggleable editor mode. So I'll make a variable for all sprites called editor. And in setup, I'll set editor to 0. Let's have 0 be the key to toggle the editor on and off. So when the 0 key is pressed, if the editor is greater than 0, we'll set editor to 0. And if it is not greater than 0, then we'll set it to 1. Now around this whole touching mouse pointer, make sure the title index and change X stay out of it. We'll check if editor is greater than 0. So this means we can only place tiles in the editor. Let's see if this works. So we press 0, and now we can place tiles. And then we press 0 again, and now we can't. Let's also disable collisions for the player in the editor. If editor is less than 1, then we will want to handle the collisions. Let's also make it so we move a little bit faster in the editor. So if editor is greater than 0, I'm going to duplicate this so we move twice as fast. Again, I'll do the same for speed Y. So let's normal speed, open the editor, and we move twice as fast and we can walk through walls. Awesome. And here you can see our animation frames. We are clearly animating much faster, like this. Fun. Alright, and that is it for this video. I hope you enjoyed it. Have a great rest of your day, and goodbye.